Hello folks, and welcome to the channel. Here we have a baby AT Jetway J542C motherboard, which I've been scouring the internet for and of which I am particularly fond of. Unfortunately, I have no idea where my original motherboard ended up, but I did manage to find the original manual, which may come in useful later. This particular motherboard is the replacement and the same one as that I used for my very first custom PC build, way back in 1999. Currently there are two 16MB EDO SIMs installed and an Intel Pentium 233Mhz MMX CPU. In 1999 I was running an AMD K6-2 450MHz CPU and 24MB of RAM, which had been salvaged from the previous system, which had been running an AMD K5-PR166 CPU. And for my own nostalgia, here is that actual CPU, which is a little bit worse for wear and has been sitting in my old man's shed for decades, and I'm a little dubious about testing it. When my old man acquired this processor, it was missing a pin on the corner and he managed to solder a thin piece of copper wire in replacement of that pin, and amazingly it worked. A technique that simply would not be possible on a modern processor. The Jetway J542C motherboard, also known as the Max Speed or the Max 2.1, is a Super Socket 7 or Super 7 motherboard because of its accelerated graphics port, or AGP slot. The board has support for a wide range of processors on a ZIF Socket 7, including the Intel Pentium, Intel Pentium with MMX technology, AMD K5, K6, K6-2, K6-3, the Cyrix 686MX, PRM2, and the IDT C6 CPU, with support for 66 and 100MHz CPU frequencies. Running on an ALI M1542 chipset with an onboard level 2 cache configuration that provides 512K or 1MB pipeline burst SRAM, support for two 72-pin SIMs and two 168-pin DIMMs, supports both fast-paced mode and extended data out SIMs, and also supports synchronized DRAM module DIMMs. For in-out ports, we have an AT keyboard connector, one floppy disk interface, two IDE interfaces, one PS2 mouse port, one parallel port, two serial, and two USB 1 ports. And for expansion slots, we have two 16-bit ISA slots, three 32-bit PCI slots, and one 3.3V AGP slot for 533 megasecond data transfer rates and 66 to 133 MHz bus clock to improve graphic functions. Onboard PCI busmaster controller with two connectors that support 4 ID devices over 2 channels and provides faster data transfer rates and supports enhanced IDE devices such as tape backup, CD-ROM drives and the LS120 drives. This controller also supports PIO modes 3 and 4 and busmaster IDE DMA 33 and 66 MB per second. At the time this was a fairly advanced motherboard. With the technical aspects of this motherboard covered, and a brief talk about my own personal nostalgia towards this board, you can see that I'm putting together a little desk rig to see if we can get a picture. This particular motherboard has come all the way from Perugia in Italy, and upon arrival I had noticed that one of the capacitors had been bent and the pins to the voltage settings for the CPU had also been bent and the jumpers had come off. I had to spend a little time correcting both of these issues and setting the correct voltage settings by referring to the manual. The graphics card we are going to be using on this test boot is an ATI Radeon 7000 AGP graphics card with 64MB of DDR video memory. This card also has an S-Video out, so I can attach this to my HD PVR to capture the display output. I think we're now ready for a test boot. Ooh, and would you look at that, we've got a post screen. Absolutely beautiful. I love it when old retroware just works after 20 years of retirement. From what I've experienced, the hardware of this era tends to be pretty robust and relatively easy to repair. In most cases, a good clean and replacing of capacitors is all that is really needed. They are not like modern motherboards where everything is surface mounted, and it can be a bit of a pain when those components need to be replaced. And the majority of the time, these boards end up being scrapped. Now that we have verified that this motherboard is working and we've got a post screen, it is time for some maintenance to keep this board in operating condition. As you can see, there are 4 bulged green capacitors located next to the CPU socket. All 4 capacitors have now been replaced and the board is now ready to be put through its paces, which I enjoy doing with all of my vintage motherboards, performing a good old Dosbench to verify that everything is working as intended. For the first Dosbench, we'll be using the board in the configuration that it arrived in, with a 233Mhz Intel Pentium MMX CPU and 32MB of EDO memory. And for display, we'll be using the ATI Rage Pro AGP graphics card with 8MB of SDR memory. Right then, let's build a little desk rig. As always in my DOS-benching videos, the compact flash to IDE adapter and a micro drive with DOS 6.22 installed is what we'll be using as the boot device. Time to power her up now, and this is the first time since the board has been recapped. But we know that it was working beforehand, so hopefully, yep, excellent, we have a post screen. We'll be taking a look at 3D Bench version 1.0C for faster PCs, PC Player Benchmark in 640x480, Doom in max detail for faster PCs, the QuickTime demo in 640x480, and finally SpeedSys. 3D Bench version 1.0C for faster PCs scores 160.1 frames per second. PC Player Benchmark in 640x480 scores 23.9 frames per second. Doom timed 2,134 game ticks in 753 real ticks. That is about 99.2 frames per second. The QuickTime demo in 640x480 scores 15.6 frames per second. Now on to speed test for some more detailed performance parameters. Processor indeed is an Intel Pentium 233Mhz MMX CPU with the codename P55C and an external clock frequency of 66.65 MHz, times by 3.5, 32 MB of memory with a 142.73 MB per second memory bandwidth. ATI Rage Pro for display with 8,192 KB of memory with a 74,044 KB per second memory bandwidth. Motherboard chipset is the Acer ALI M1541 Aladdin 5, and this board, known as the Aladdin 5, with its award modular BIOS version 4.51 PG, dated the 10th of the 10th 1999, and we're running DOS 6.22. The processor benchmark scored 174.47, right on the marker for the P55C 233. The extended memory timings results are as follows. The 16 KB data cache level 1 transfers 424.80 MB per second. The 512K data cache level 2 transfers 175.69 MB per second, and the memory throughput is 94.43 MB per second. The test went pretty well, and verifies that all is working well. Now, let's rip out this Intel Pentium 233Mhz MMX CPU and replace the processor with something I'm a little more familiar with. This is an AMD K6-2 450 CPU, which is the replacement to the processor that I'd been running paired with this motherboard. I was just 15 when I built my first custom-built PC, and these were the components that I had used at the core of the system, running slightly more memory in these benchmarks, but we should be able to get a good idea of the performance of this setup. So games that I would have been looking at playing around this era would have been games like CNC Tip Sun, Half-Life, Homeworld, SimCity 3000, Quake 3 Arena and Unreal Tournament, and so on. Before I can fire this desk rig up, I need to just adjust the core voltage, front side bus frequency and clock speed multiplier for the CPU. Thankfully, I do not need to refer to the internet because I still, indeed, have my original manual to refer to. To set the correct core voltage, I need to jump at pins 3 and 4 To select the correct front side bus frequency, we want switches 1, 2 and 3 to be off, and to select the correct CPU frequency of 450 MHz using the clock speed multiplier of 4.5, we want switches 4, 5 and 6 to be on. Now that we have all of the jumpers and switches set to the correct values, we can now fire this up and run another Dosbench to check that this K6-2 CPU is working correctly. We'll be taking a look at the same benchmarks as the previous Dosbench, 3D Bench version 1.0C for faster PCs, PC Player benchmark in 640x480, Doom in max detail for faster PCs, the quick time demo in 640x480, and finally SpeedSys. .3D Bench version 1.0C for faster PCs scores 218 frames per second, up from 160.1 frames per second scored by the 233Mhz Pentium MMX CPU. PC Player in 640x480 scores 36.9, up from 23.9 frames per second, an increase of 13 frames per second. Doom timed 2,134 game ticks in 613 real ticks, and that is about 121.8 frames per second, up from 99.2 scored by the 233Mhz Pentium MMX CPU. The quick time demo in 640x480 scores 17.3 frames per second, up from 15.6 frames per second. Now onto SpeedSys, and all there is changed here is the processor now showing as an AMD K6-2 450 CPU, with the code name Chomper XT, and with an external clock speed of 99.99 MHz, times by 4.5. We have lost a little memory bandwidth on the ATI Rage Pro, down from 74,044 kilobytes per second memory bandwidth on the 233Mhz Pentium MMX, down to 66,655 kilobytes per second, which is rather interesting. I would have expected this to have been roughly around the same, if not marginally faster. The processor benchmark scored 510.15, and we're not touching any markers, but you can see we are right between the Pentium 2 400 and Celeron 500, so we are where we are expecting the CPU to score. Now let's see if there's any changes to the extended memory timings, and the results are as follows. The 32KB data cache level 1 transfers 1,320.25 megabytes per second. The 512K data cache level 2 transfers 294.45 megabytes per second, and the memory throughput is 130.74 megabytes per second. Big changes here, certainly a lot faster on all of these results. That is the Dosbench now complete, which brings us to the end of this video. Thanks for watching. If you have any comments, please leave them in the comment sections for me. Take care, and I'll see you in the next video.